Okay, welcome back. Day 3 of derivatives, Unit 13, Intro to Calculus. Remembering two things we learned yesterday. F prime, the symbol for derivative. We did this example yesterday. F of x equals x squared plus 1. We found the slope rule to be 2x. At the end of the video, we found f prime of this one to be 6x minus 2. I started to evaluate f prime. Remember, that's a point, so we're just going to use the x. 6 times 1 minus 2. So the slope of the quadratic equation at the point 1, 2 would be 4, the slope of that tangent line. We're going to do one more because we're then going to find a pattern. Because if I asked, or if you asked one of your friends to find the derivative of that f of x equals 3x squared minus 2x plus 1, they could do it in their heads. And it's not that it's magic, they did all that work. There's something called the power rule we're going to learn. But we first have to be very good at this f prime, this derivative. So I want to first find the derivative of this x cubed. And what do we remember it as? Limit as h approaches 0, f of x plus h minus f of x all over h. Which means x plus h cubed minus x cubed all over h, limit as h approaches 0. I know what f of x, or x plus h squared is. I don't know what x plus h cubed is. So I'm just going to say x plus h cubed equals x plus h times x plus h squared, which we said was 2, or x squared plus 2xh plus h squared. Now we're just going to distribute through. Again, with math, you can do everything. You can figure everything out. So x times x squared is x cubed. X times 2xh is plus 2x squared h. X times h squared is plus xh squared. H times everything is x squared h. Notice I lined it up underneath its like term. H times 2xh is 2x h squared. H times h squared is h cubed. So if I added this all up, I would get limit as h approaches 0 of x cubed plus 3x squared h's, because if I added these, plus 3xh squared plus h cubed minus x cubed, not 3x, minus x cubed all over h. Not as much cancels on this one, just the x cubed and the x cubed, leaving me with limit as h approaches 0, showing every step. 3x squared h plus 3xh squared plus h cubed all over h. Still can't plug the 0 in for h because of the h denominator. We'll pull the h out, leaving us with 3x squared plus 3xh plus h squared all over h. We can now cross those out. We can now plug in. We still have to write it, showing all of these steps. The mathematical rigor is what we call it. Now we can take that 0, plug it in for that h, plug it in for that h. So what is f prime of h cubed? Answer, 3x squared. Pardon me, f prime of x cubed is 3x squared. All right, so now we're going to do the pattern part. Now we're going to figure out a shortcut. Now we're going to see if we can find the derivatives without all this limit work, and we can. Okay, we're going to build this new powerful tool. It's going to be called the power rule. So we know all about this definition of derivative. We know we're finding the instantaneous rate of change, the slope of the tangent line, unlike the slope of the secant lines, which we did old school. Okay? Now, this is what we found. The derivative of that function was that function. The derivative of that function was that function. Derivative of that function is that function. This one we didn't get a chance to do. What is the pattern? Give you a couple seconds to think. you could pause this, you could turn this off, and you could see if you could figure out. It's definitely a pattern that you can find. Give yourself some time. That's mathematics, figuring things out. Sir Isaac Newton was the person who developed calculus. He came up with these ideas. It explains the universe. Mathematics is a language of science. So if we got an idea, how can we turn x squared plus 1 into 2x? But at the same time, that rule turns 3x squared minus 2x plus 1 into 6x minus 2, x cubed into 3x squared. We won't worry about example 4. And if you found the pattern, we'll apply it here. This 2 gets down here. So that would give me 2x. And then 2x is x to the first, so that 2 gets down 1. Okay? What happens to a constant? Seems to be gone. I don't know. So let's go to the next one. 3x squared minus 2x plus 1. Well, again, the constant seems to be gone. That 2 is brought down front. That 2 could be brought down front, but there's already a number there. 3 times 2, 6x. 2 minus 1, x to the first. Sure enough, that x would be a 1. 2 times negative 1. 1 times negative 2 is negative 2. 1 minus 1 is 0. But x to the 0 is just 1. 6x minus 2. Hey, we're on to something. Let's do our last one. X to the third. Bring it down front. 3. Subtract 1. X squared. Bingo. Okay, we'll come back to this fractional one in a minute because it's important as well. So, this is called the power rule. If I have a function, f of x equals something x to some number, ax to the n, then f prime of x equals, what are we going to do to that n? Multiply them together, a times n, x to the n minus 1 power. Very, 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 all that limit stuff, it would work every single time. This is a quicker way to get it. How cool is math? So here's an example. If I had the function 5x squared, no more limit definition. We can now use the power rule. 5 times 2, x to the 2 minus 1. The derivative would be 10x. And then if we wanted to find the slope of the tangent line at any specific point, like let's say we wanted to find the slope at 3, we would just plug 3 into f prime, and the slope would be 30. Very, very steep line. All right, so now we're going to use just the power rule. Okay, we're not going to use the limit definition of derivative. So what's the derivative of x to the fourth? 4x to the third. What's the derivative of 2x to the 7th? 14x to the 6th. What's the derivative of radical x, or 1 over x? Well, what we're going to have to do is we're going to have to write them exponentially. What's another way to write radical x? X to the 1/2. Now I can use that power rule. 1/2 goes down front. 1/2 minus 1. What is 1/2 minus 1? 1/2 x to the negative 1/2. Negative 1/2. 1 and 2, there's our 1/2. Moves it to the bottom. Raise it to 1/2 power. But the best answer is 1 over 2 radical x. So the derivative, and again, when you take calculus next year, that's a standard one you'll have memorized. F prime of radical x is 1 over 2 radical x. And now you could find the slope of any tangent line at that curve simply by plugging into 1 over 2 radical x. So let's take one more. I'll do it in green real quick. What's f prime? Well, 1 over x is also known as x to the negative first. If I use the power rule, I'd bring negative 1 down front. I'd subtract 1 from negative 1 to get negative 2. And what's that if I said no negative exponents? Negative 1 over x squared. The derivative of 1 over x is negative 1 over x squared. And the cool thing about derivatives, now, what if they get messy? What if they get lots of terms? If you want to find a derivative of a function that's made up of a bunch of pieces, you find its derivative by finding the derivative of each piece separately. That's a very, very, very important statement, rigorous mathematical statement. So let's take this. Again, no more limit definition of derivative. What is f prime? Let's use the power rule. 6 times 2 is 12. 2 minus 1 is 12x. Exponent 1, 7 times 1 is 7, just 7. And if you think about it, 7x by itself is a line. And a line has a standard slope. And what's the slope? 7, sure enough. Okay? And the constant is gone. Now, what if I had a crazy function? I would not, me personally, I would not want to do this one with the limit definition. But what my first job is I'm going to rewrite it exponentially. Rewrite exponentially. 2 over x squared, 2x to the negative second. Cube root of x, x to the 1/3 plus 5x. Now I can apply the power rule. Negative 2 times 2 is negative 4. X, be careful. Negative 2 minus 1 is negative 3. Negative 1 times 1/3 is negative 1/3. X, 1/3 minus 1 is negative 2/3. Derivative of 5x is just 5. That's an easy part. But now I got to rewrite, because we may not have the option of negative exponents or fractional exponents. So what's another name for negative 4x to the negative third? Only the x is raised to the negative power, so the 4 stays up, the negative 4 stays up. X cubed moves down. Negative 1 over 3. It's going to move down. Plus 5. And one last step, let's say there's no fractional exponents either. Besides negative, there's no fractions. 1 over 3. How could I rewrite x to the 2/3? Cubed root of x squared. That right there is f prime of x. Good practice for you. It's really a lot of exponential work. Okay, one last one. Let's do it over here in blue. Rewrite 6. Square root of x to the 3rd would be x to the 3/2. 1 over radical x would be plus 1 x to the negative 1/2. Negative was down. Radical means 1/2. Now we're going to apply the power rule. I'll write it the long way. 6 times 3/2, x to the 3/2 minus 1, plus 1 times negative 1/2, x to the negative 1/2 minus 1. Now we just got to do some cleaning up. 6 times 3/2 is 18/2, otherwise known as 9. X to the 3/2 minus 1 is 3/2 minus 2/2, which is 1/2. 1 times negative 1/2 is negative 1/2. Negative 1/2 minus 1 is x to the negative 3/2. And again, if it didn't say, we could leave it like that. We'd be done. If we can't have fractional exponents, 9 radical x. If we can't have negative exponents, the 1 stays up, the 2 stays down. This moves down. X cubed square rooted. There is f prime right there. And again, no more limit definition of derivative, just power rule. All right, looks like that's just about time. Got a really good exposure. I wish we could have done more. I wish we had more days to do it. Normally we do about 5 or 6 days. We were only able to do 3. If I can find the time and we can talk, I'll talk to Mr. D about it too. Maybe we'll put another video or 2 together dealing with particle movement and what's called the second derivative or acceleration. But if not, at least we got you exposed a little bit to some calculus. And hope you had a really good year. I really enjoyed teaching all you folks. I know it was a terrible end, especially for your seniors. Your high school career didn't end anywhere near what you thought it would, what it's ever been for anybody else, but you can have some great memories. Just the uniqueness of 2020 with your surgical masks and social distancing. So again, thanks a lot, guys. It's been my pleasure to teach you, and have a good rest of your life.